Okay, I guess we'll get started. So we're really happy you've chosen to join us this afternoon for the OpenXR Forum Symposium. Thank you for attending. A couple of things to start with. There's water over here for anyone. Excuse me. There'll be some food brought in around between 12 and 12:30. So when that arrives, feel free to stand up and grab something to eat. That's part of the package. Also, the session will be recorded, so watch what you say. But it's recorded so that people who can't attend, because it's a busy conference, will have an opportunity to listen in and learn later. So with that, we'll get started. So I hope you'll learn something interesting and maybe useful today from the presenters. For example, why have we formed the OpenXR Forum? What's the work product? What are we doing in the OpenXR Forum? And then maybe learn something about some of the interesting applications and capabilities that OpenXR hopes to make possible. So we'll take a look at the agenda. So we'll start with 3 presentations from some visionary network operators to talk about applications they envision. Andrew Lord from BT. Let's see. I have a change here. Emilio Riccardi from Telecom Italia Mobile. And from Telefonica, it will be Oscar Gonzalez de Dios. Will be standing in for Edward. And then Norm Swenson will walk you through the OpenXR specification roadmap. Steve Hand will discuss 2 proof of concept demonstrations that are being worked on in the OpenXR Forum. And then David Peeler from Dell Technologies and Moran Roth from Juniper Networks will talk about OpenXR from the perspective of a network equipment manufacturer. So let's go forward. So motivation. Why did we form the OpenXR Forum? So coherent optical technology is moving closer to the edge of the network. We all understand that, and at some point it will become a pervasive technology. We believe Nyquist subcarriers will enable point-to-multipoint coherent optical networks, including a coherent overlay to PON networks. And third, advances in ASIC technology have increased the intelligence and functionality that can be put into a pluggable transceiver now. So this kind of has 2 benefits. In some applications, it can eliminate the need for a transport box in addition to or separate from a layer 3 router. And it enables a new management paradigm that simplifies the integrated management of transport layer and higher layer devices in the IP or application domain. So to take advantage of these benefits, we believe it requires a parallel effort to align with carrier operational modes, existing MSAs, and interfaces. And if necessary, create new specifications if they don't exist in current MSAs or standards. So the OpenXR Forum is a network-driven collaboration between network equipment manufacturers, component suppliers, and carriers. Our purpose is to accelerate the adoption of intelligent coherent pluggables and point-to-point coherent networks, establish an interoperability between low-speed transceivers and higher-speed transceivers, enable software configurable bandwidth, and define host compatibility for this new class of devices. and of course, create a healthy and diverse supplier chain, supplier ecosystem. Let's back up. So the organization, there's a core group of carriers that join to form the forum, create the operating rules and directives. There's a group of participating members that focus on defining application requirements, and then working groups comprised of both types of members that focus on proof of concept demos, defining interoperability requirements, and identifying new specifications that need to be written or introduced to other standards and interoperability groups. So this is the current membership. It stands at 21 members, 12 operators, 9 software and network equipment manufacturers. And we are, of course, open to new members. So what have we done? We've published 2 white papers, an introductory white paper to the concept, a white paper on introduction to applications. Our first specification covering an OpenXR management architecture, which will be discussed in Norm Swenson's presentation. We've contributed we've made a contribution to the OFI CMIS 5.3 for a configurable lane mapping that we hope will be adopted, and developed a draft specification roadmap. And then finally, you'll hear from Steve Hand of 2 proof of concept demonstrations. You'll hear more detail that are currently being worked on in the forum. So we'll start with the first application presentation from Andrew Lord of BT. There you go. There's a microphone right here. They'll turn it on.
Hi everybody, thanks. Can you hear me? Hello, testing. Wave, if it's working, cool. Visionary, I really like that actually. Thank you, Philip. So it makes me feel really, really warm. Also, the warning that we're being recorded, so to be careful. At one of these kind of virtual events over the summer, I described XR as PON on steroids, and that's kind of gone. Well, it's not gone viral because this community isn't viral, but it was certainly has been captured as a phrase, which I highly regret. Especially my team at home find it hilarious that I've used that phrase. I'm going to be more careful today. Right, let's see if this works. Cool. So my use case, and we have quite a few use cases, but I wouldn't say they're cemented yet. So I think there's still a lot of work to do to decide exactly what the sweet spot is for this technology. So let's unpack that. But it's going to look something Metro-like. Okay, I don't think it's a core technology. I think that the bit rates are too small. So it's a Metro space, and that's where the volumes are. I think that's where much of the challenge is going to be. Clearly, coming from the mobile wireless community, there's a lot of demand coming there. So what does that look like? And I think it'd be nice to present some real data. So here's my data slide. And it's kind of showing you typical lengths of nodes in a BT Metro network. So there's kind of 2 plots. They're the same thing. Really, the top one is looking at typical spans in a Metro network in the BT network. You can see the kind of peak is around 10 kilometers, but there's a very long tail. It goes on to several tens, maybe 100 kilometers, and they're clearly more kind of rural regions, rural areas. The bottom one is the same thing, but it's looking at what you do when you turn those metro links into chains, which is how we tend to build our metro networks. We tend to build these horseshoe connections. So going from one node to the metro node at the end could end up going through everything. So it ends up being a longer distance. So the bottom one is kind of shifted to the right. But anyway, that gives you the sense that we're not looking at hundreds or thousands of kilometers, okay? But we're still looking at reasonable bit rates. For what? Well, I mean, firstly, there's this 30% year-on traffic growth, which continues, has been going for the last 20 years or so. And then what does that mean for the metro? And the metro has to kind of carry everything. So it's carrying, for sure, mobile traffic, but it's also carrying all of our internet, all of our business customers as well. And the radio side is the side that is really interesting and dynamic, because there you're thinking about putting more macro cells and ultimately small cells out there. With requirements around 10 to 25 gigs, which feels like a really good sweet spot for this technology. Now, I don't need to put this slide up because this is an XR community, and although you didn't put this up, Philip, so maybe we do need to do a quick summary of what XR is if there's anybody out there that's not actually heard of this yet. Where have you been? But basically the idea is it's point-to-multipoint. So you have a head end that in this case is a 400 gig digital subcarrier head end, and it's not point-to-point connecting to its endpoints. It's going through a splitter, or it could be a wavelength component. But essentially it's one to many, and that many could be 4, or it could be 16. It could just be 1 if you want to make this into a point-to-point mode. But the idea is each of those endpoints there is picking out their part of the spectrum. So there's some management playing going on to allow those endpoints to tune into the bit that they need. So what essentially you could have 400 gigs going to many 25 gigs or 50 gigs or 4 times 100 gigs. So what you're doing is a kind of an automatic layer of aggregation. On top of that, you're reducing box count by almost a half. So you would expect a degree of cost saving just from that. Added to that, you can put this component here on the right into a router, and we're going to talk about that in a minute, but that gives you even more benefits. Okay, so that's XR. And what we've been doing for the last 2.5 years or so now is really looking at the potential for this mapped onto those metro networks that I showed you on the first slide. So this is all published, ECOC and OFC, joint papers with Infinera, and the results are quite dramatic. But they're not surprising. If you halve the number of boxes in your network, the costs are going to go down by 50%, or more if you start to integrate the routers. And so that's what you can see here. We've basically done, bear in mind this is a while ago, so this will have changed. We need to do this work again. But at the time, we're looking at different kind of comparisons with, as you can see there, different types of point-to-point technologies. And XR has done very well. Now, at proviso, we need to do this again because clearly the point-to-point community are changing. And, there are things like 100 gigs that are emerging. Not here yet, but, 26 are manufacturing 100 GZR modules. So how does that play into it? So don't take this as now up to date. It needs to be redone. But look at the potential. Potential is really quite incredible. What I haven't done on there is looked at the power savings that you might get, but I think that's something we should try to superimpose on this. That's what we need to do to look at the benefits of that. One more thing I want to say, though, and that is to do with where does it fit, and because it's point-to-multipoint, so you would expect it to fit very well on an architecture that is already point-to-multipoint. We're calling it hubbed, and there's a really awkward term, hubbedness, which is impossible to say, so probably should just scrap it. But it's really a way to try to measure a network that aggregates. In your core network, you don't get a lot of hubbedness because everything's kind of going everywhere. But in the access domain, it is really very hubbed. Traffic is all heading in one direction. So it's those hubbed architectures that are a real sweet spot for XR, because XR fits the kind of traffic flow, the traffic matrix that it's trying to handle. Okay, so this paper here is really trying to put some theoretical work on what that means. I'm not going to go into detail on this. I think we've got some probably more technical talks coming up later. But suffice to say, and we have, I think, Juniper here as well. Moran is going to do some discussion on how XR gets into the router, because that's, again, not trivial. If you want your router to be able to understand what's happening at the 25 gig level for a single 400 gig pluggable, something has to be developed there. So work to be done. You can see some discussion there on how that might happen. It's not rocket science, but it does need to take place. I think the benefits, though, are huge. If you can start to have a router point-to-multipoint optics kind of interface all in one, then you've missed out a whole load of chunks of your network, which is going to save a lot of operational costs and basic capex. Okay, I'm nearly finished. I just want to kind of pull it together and then hand over to Emilio. I'm not going to categorically say it's this use case. I think the use cases are around the metro, but exactly whether they are RAN associated or a more generic metro play, I don't know. Work is carrying on there. We are excited to see pluggables over in the exhibition and hopefully coming into labs in the next few months or so. I'm really excited to see how that will translate into router integration. That's probably a little bit further away, but hopefully that'll be quite quick. And generally, you know, it's an excitedness, but with some pragmatism that there's still work to do, and there are competitors, of course. And so I don't think it's not a slam dunk yet. So yeah, really exciting times ahead. Thank you. I think questions come in a bit. Okay, no problem.
Okay.
We'll do questions after the application. We'll do it in sections.
Going.
The arrow key?
Okay.
There we go.
Okay.
It's a little sticky.
It's got it. Okay. Okay, thank you. I'm showing something that is quite similar from the network perspective, what was shown by Andrew before. And the possible, maybe it's pointer, I don't know. No pointer. The application of XR optics in the regional aggregation network. So,
Right arrow. Yeah.
this one?
Yeah. Point it somewhere. There you go.
I see. Okay. 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 That's. I want to show first the context we have. So what is shown in this figure is the architecture of the metro regional network of Telecom Italia. That is all distributed all over Italy. We have several of these metro regional network, one for each network in Italy. All are more or less 14. Okay, so it's made by two segments. The first is the regional core shown in yellow on the top right, and it is a mesh network that the size of that network is of the order of several hundred kilometers. The nodal degree, as you see, is more than 2, it's 3, 5, it depends on the size of the region. And also the traffic is not an hub traffic. It made a mesh traffic. And you see the boxes in red with the R are ROADMs. Inside the regional core, we have a high quality, let me say, ROADMs, which correlates, directionless functionalities, and coherent system working there. If we move on the other segment of the network, which is called the regional aggregation, that is the topic I want to highlight right now, you see a more simple architecture. First of all, look that there are two hubs that are regional POPs, I hope. Okay, this one and this one that collect all the traffic coming from this lift node. So one regional node is collecting several local nodes. And of course, from here it starts the access part. Okay, we have some sort of first grooming here with a router, a switch, and not important, but grooming the traffic from the access. Then a second level of grooming here, that collecting from up to 7 typically nodes in a dual hub traffic to these two feeder point, and then the traffic is distributed in the metro and maybe in the national part of the network and in the big internet and so on. So the traffic here is naturally hubbed. So it's quite natural to consider to have the same point-to-multipoint architecture in the optical layer. You know that up to now it was not actually fit. Yes, you can use PON or something like that, but distances are too big for there. Another point, important point, is that the traffic from most of these lifts to the hub is typically few 10G right now. So 25G fits really well, and multiple of that is quite good for this kind of region. Of course, now if we want the compatibility of the existing, that could be a challenge. First, because we have now we have 10G. So you mean 10G means compensated network, of course, because otherwise it will not work. But I mean, I don't think that is a big issue also for Korea. But anyway, remember that, take that in mind. And the second point are we have ROADMs. The degree 2 ROADMs, what does it mean? Is a ROADM compatible with a point-to-multipoint architecture? The answer is, for the technology we have, the answer is not. That is the big issue we are facing in introducing point-to-multipoint solution in this kind of network. Of course, things are continuously evolving, so we can, of course, have a new installation from scratch. In that case, we can use different technology. One solution could be to be completely passive. That is fine, really very low cost, but the operational cost maybe could be high sometimes. Anyway, there is a critical point. If we want to have ROADMs, we like to have it, for example, for to equalize everything in an automatic way for provisioning, not for strange things, but for simple things that we can do remotely. We have to solve this problem. What means that we have to have the drop and continue functionality inside the ROADM. Now we don't have. But anyway, consider that is the context. And okay. We have at least 3 use cases all related to this regional part of the network. So the idea is the first one, the simplest, let me say, is to use the XR to collect traffic. And we have already done, together with Infinera, some study on this kind of the network. And actually, we can have really less transponders, which means a cost and a good saving in terms of CapEx for the network. And the other point, which is really good, is that we can eliminate theoretically, at least now, but in future, I've seen in the booth it's feasible, to eliminate transponders. So we can use the modus directly inside, at least theoretically, of the routers. And of course, a sort of pace as you go, because we start with 25G and so on and so on. And that's compatible with, potentially compatible with a WDM system, so we can have more than one in parallel. That's really good. Of course, brownfield is a problem, not only for the compatibility with the switches, that is something that the consortium and Infinera is working on. I'm sure it will be solved very soon, but for the ROADM, as I said you. The other application, but a bit more far, is that XR optics allow us to follow some way, in a dynamic way, the behavior of the network. So remember, we have only 7 nodes. 7 nodes is less than 16 channels that are from the XR. So maybe you can switch on another 25G. You have everything there. That's the problem. In the past, you have to include a new transponder. Now the transponder is there. And the third is why not move coherent up to the final user? That's interesting, but cost, we don't know. And my last slide. You know that are the problem. First, XR optics are in some way unlambda. The scenario is always something like an open line system or a system from one vendor and XR from another vendor. And so you have to manage everything. Not so trivial, but of course that means that we have to standardize something in that context. Compatibility with the router, but again, costs are more important in the lift nodes, where probably one wants to install only 100G total capacity, and maybe have use the less power, the most widespread form factor possible, and so on and so on. Oh, so complexity of managing is something that is clear, but it's one of the topics of the XR forum. That's all. Thank you.
Which one to pass?
This one. This one, the point is here.
Okay, perfect. Okay. Okay, great. So now let's discuss some additional network scenarios that we can consider for the application of XR and some of the challenges that we see for the control plane and to integrate with all the automation that we are doing in the operation. So let's see that there are two complementary things, okay, and let's go for each other. So just, first of all, remind how is the Telefónica's network architecture. This is our fusion architecture that we apply in all the countries of Telefónica, so it's very hierarchical. So the important points, okay, and we will see that for each of them we might have a different application of XR, is we have the more capillary layer is the HL5, this is the one that is connecting to the base stations. So this is let's say the more number of these small routers that collect the traffic, and how do we get it to the packet core and to the caches? They are located at the HL3 layer, so we now do an aggregation via the next hierarchical level, the HL4, so it's a relation more or less a 10 to 1, okay, of these aggregations, and then we go to the next aggregation point where we have all the caches located. So, for example, of the Netflix, Facebook caches, etc., where are there. So now most of the traffic, let's say, will end up here at this layer. Okay, so this is the main context, and here in the HL4 is where we are aggregating all the fixed customers. Okay, fixed customer and business customers come here mainly at this HL4 layer, or sometimes directly at the HL3 layer if the customers are very big customers. Okay, so what can we do with XR? Okay, so we can start. Okay, let's start with just with a point-to-point. Okay, so. Okay, perfect. We still have, and we will have point-to-point still in many cases. Okay, so for example, in the HL3 to HL4 connections, remember that we still have a lot of residential traffic that it still counts for a lot of them, and it goes all the traffic to these Netflix, etc. caches, and there we see, for example, there we see that we have a traffic daily variation, very well known. Traffic variation, so it's not something that changes or the pattern changes dramatically from day to day, so it's very well known. Okay, so there one potential application is can be okay, adjust the port of the speeds to the real needs. Okay, that several years ago you can tell us, okay, energy savings nobody cared. Okay, now things are completely different. So I think this kind of studies need to be completely redone. I mean, now the situation that we are facing in the world is completely different than from a few years ago. So these kind of scenarios start to make sense. Okay. Another is considering that we have a similar growth as BTs. We have 30% more or less continuous growth each year in total. So also that we can install and we can progressively grow without having to change the installed plan. So this just for the point-to-point, even we have some application scenarios. Then we have, thanks to the point-to-multipoint, we have a few scenarios that we can re-architect our network. So those, I think, we are similar situation than BT and Telecom Italia, where we see that from this first level of aggregation, we can concentrate all of this with the point-to-multipoint from the leaves to the hub, and is quite reasonable. So we have done similar studies as you, and we can see that we can skip one of these aggregation layer if we are able to do it with the point-to-multipoint. Okay, so here this is an example, and here depending of the different capacities, we could go for 150 or 25 gig in the leaf nodes. Okay, so here we have done several studies together with Infinera, and we found big potential savings in implementing that. So then, I want to jump a little bit also into the SDN requirements. Okay, so for us, it's as important that it is the CapEx of the network. Also, it is important that we are agile in provisioning our network and in automating all the network. So here, Telefonica, we defined several years ago the fusion architecture. We shared also this architecture with other operators that standardized this architecture, and we defined, for example, for all the optical network, use Transport API to be able to handle all the DSR and media channels, and for the management of the IP devices and the open terminals, use OpenConfig data models. And that we not only define it, but also we are implementing it. Okay, so it's put in the network with those requirements, and we have the IP controller and optical controller, and starting to integrate those elements. Now we are evolving, and now we are thinking in this IP over WDM. So this is still a work in progress. Okay, here we still have several challenges. So here in the different or we have different groups, okay, where we are working in the fusion architecture. So for the IP over WDM, so for example, in the B5G Open Research Project, we are precisely doing this IP over WDM. In the Telecom Infra project, we are also working, and we have, whether it's one SDN controller of the optical or another IP. So it is something still working in progress. And we have some big challenges here for the OpenXR. Okay, so the dual management. Okay, so here we have the dual management of the what do we do with it? In the point-to-point, it is clear that with OpenConfig we can manage everything. Looks like a regular transceiver, so we can, let's say, get most of it. Maybe in the telemetry side, maybe there are some specific things of the XR that are not transported. But I think most of the functionality that we require, let's see, for the scenario that we mentioned at the very beginning, so to cope with this dynamicity, to be able to switch on and off, maybe we need to do some tweaks. Okay, so maybe we need to do some tweaks. But then for the point-to-multipoint scenario, to be able to transform this into leaves, and there we have challenges. Okay, so there is where we need to, on the one hand, for the optical network, we need to introduce the concept of point-to-multipoint media channels. Okay, that is not there. Okay, we even need to model that. I mean, it's not there. It's not done. So here we have also several initiatives that we are working together with researchers and with industry to be able to get that. And also another question that appears is, okay, can we do some abstraction on top of current device level to say, okay, this point-to-multipoint might be modeled at a network level, and we can say, okay, what I want is from this hub to these leaves, I want this connection. So have an abstraction that maps this. So is it possible to that abstraction? Where would it go? In the optical controller, in the IP controller, in some intermediate controller? So that is still open for, and I hope that here in this forum we can answer that questions. Okay.
Thank you. So I'd like to open it up for a few minutes of questions before we discuss the specifications and proof of concept demos, if there are any questions. Otherwise, we'll continue. No? Okay. Norm? Thanks. And there's a pointer.
Hello, can you hear me? Okay, great. Right. Hi, I'm Norm Swenson. I'll be talking about the specification roadmap that we're developing within the OpenXR forum. I want to start with a motivation for how we're approaching one of the challenges, which is the management of these XR transceivers. And if you saw Dave Welch's plenary presentation yesterday, this will be a repeat for some of you. Excellent presentation yesterday, Dave. And so, apologies to those of you who've heard this before, but this really sets the stage for why we had to attack the management of these XR transceivers in sort of a different fashion from what has been done traditionally. So, if you look at how the optical network has evolved over the last 30, 40 years, we have this nice layered structure which has served us very well. You've got an application layer, you've got an IP or packet layer, and you have a transport layer. And you have controllers up here, different software controllers for each of these separate layers. And that works well. You've got personnel who are trained in the different layers. They have expertise in their particular domains. And you've also got a line system that's pretty much developed by one vendor out there. So you've got one vendor who is developing the transponders, the amplifiers, the filters. They have written the software that monitors the alarms, that measures signal-to-noise ratio, all those things. Well, that's great, but then we got into this open line system. And that now allows different vendors to have transponders that are attaching to this line system that was developed by potentially a different vendor. So you still have to do things like power control and monitoring of alarms and measuring of signal-to-noise ratio. So that's where these standards and specifications came about, and they were developed so that these systems that were developed by different vendors could talk to each other, and they would understand when alarms are raised and all that coordination works going on in, for example, OpenROADM, MSA to define these things. Well, that's working fairly well for the open line system, but now we're in a situation where we're taking what really used to be a rack or sometimes several racks of equipment and shrinking it down into this pluggable transceiver, which is, smaller than this pen that I'm holding up here. And this pluggable transceiver can now be embedded in any different type of host. It's no longer in a transport box necessarily. It may be in a router. It may be in an application in a server. So, okay, how do we manage this now? There's a lot of functionality that are built in these transceivers. These are very, very powerful devices now. There's lots of issues that have to be dealt with in the transport layer. The software up here, these domain controllers, they don't know anything about that. And largely the personnel that are responsible for that part of the network don't know anything about those issues either. So you've got a real challenge now. How do you manage it? Now, I'm addressing this with respect to XR, but this is not an XR specific problem. This goes for all of these pluggable, very intelligent transceivers. You take a 400ZR or a 400ZR plus transceiver, 800ZR, you plug it into a router or in a server. You have to figure out how to manage that. So what we've done within the OpenXR forum is developed a new sort of a paradigm for doing that management. And that's the architecture, the management architecture that I'll be talking about in the next couple of slides. So what we've done, well, before I get into that, one way to do this that you might think traditionally with the least amount of change to how we currently do things is, well, you got this orchestrator up here, so we're just going to monitor all these alarms and the SNR measurements and everything, send it all up to the orchestrator there. It's going to, and by the way, through those domain controllers for the application layer and the packet layer, talk to the orchestrator. The orchestrator is going to pass this information to the transport controller. He'll take a look at what's going on, figure out, we have to change some power levels here. We've got a fault in the network over here. And then take actions and send those back to through the domain controllers and back down through the host devices, again, down to the transceiver. But that's a very awkward way of doing it. There's all sorts of complexities involved in going through all those software layers, latencies involved, and things like that. So what we'd like to do instead is have a way to kind of cut through that and get a way for the transport controller to continue to manage these very capable and very powerful pluggable transceivers. And that's the architecture that we've defined within the OpenXR form. You can see these pipes here in the server and the router, and basically they have a sort of a transparent tunnel through those host devices so that the transceivers, the pluggable transceivers, can talk back to the transport controller, the OpenXR controller. Now, there's a concept, by the way, this was published in an architecture management specification, which is available on the OpenXR website. There are several advantages of this besides just the simplification that it allows, and perhaps the retention of management within certain personnel groups within the carriers, for example. There's also an acceleration of a development timeline. Now, why is that? The reason for that is that you can upgrade the capabilities of these transceivers, add new features to them. For example, I don't know, like optical spectrum analyzer capabilities that you can add into these subcarrier transceivers, bidirectionality, things like that. Features that you may not have on day one. You can add these features, and as long as you update the transport controller here, you don't have to go through and rewrite all the software in the routers or the servers that are hosting these transport devices. So it decouples the development timelines from the software development timelines of these other host devices. So this is sometimes referred to as a dual management concept, and I haven't really explained yet why it's a dual management. But if you take a look at here we go. If the batteries are going bad on this. I did. I tried that and that. I didn't try up. So dual management, because there's two paths to manage this transceiver. Path one is what you would consider the more traditional path. So you're using something like CMIS or CMIS, tomato, which is what's developed by the QSFP DD MSA. Now it's being developed within the OIF. It's a register-based management system for talking to transponders, transceivers. You plug it in, it advertises its capabilities, certain registers get set. Or in the case of like a CFP, you've got the CFP MIS, which communicates over an MDIO to the module. So that's a traditional way of doing it. You still need that. And why do you still need that? You still need that because when you first plug the module in, you've got to bring it up. You've got to establish what its capabilities are. But very quickly after that, you establish this communication link through this communication agent service, which is a small piece of software that runs in the router or the server and communicates through the DCN port back to the OpenXR controller, which sits in the cloud. So that's why it's called dual management. You have two paths of management to the XR transceiver. We are developing a number of specifications, some of which are related to the management here, others which relate more to the physical layer, with the intent of opening up this so that vendors can supply different parts of this throughout the ecosystem, and that's really what's going to drive volume and let us appreciate economies of scale. So I'll talk about these different specifications. So the first one is that management architecture. That was published back in March and is available. I've already spoken about that. The next is a couple of things going on with CMIS. We've introduced some changes so that you can have attachment points within CMIS. CMIS right now does deal with having hosts and multiple subchannels where they have MPO connectors and you have parallel fibers. We want to make that a little bit more general so that so that the mapping from the host side to the line side is not fixed and one-to-one. You can reconfigure those. So we've introduced that into the OIF, and hopefully that will be realized in the next release of CMIS 5.3, which will probably be in the third quarter of next year. In the meantime, we have a workaround for dealing with CMIS versions earlier than 5.3, 5.2 and earlier, where you can effectively accomplish the same sort of a thing, but it's not a, well, as I say, it's a workaround. I won't go into the details here. That will be published and it will be part of the transceiver specification. The next thing is the communication agent specification. That's that piece of software that goes into the router or the server. It remains relatively unchanged over time as you're adding capabilities, transport features to the transceiver and to the OpenXR controller. The next one is link budgets. These aren't standards per se, but it's really an agreed to set of applications what your reaches could be. So we're talking about point-to-point, we're talking about point-to-multipoint in an amplified hub and spoke architecture, and we're also talking about passive point-to-multipoint applications. So when we have the link budgets defined and agreed to, this is the target that we're going to. Then the other specifications that we develop for the transceivers, the TROSA, all those other ones will correlate to those particular link budgets that are agreed to. Next is a specification for OpenXR transceivers. This is going to be based, we don't want to reinvent the wheel here. They're going to be based on largely existing specifications. There's a couple of different modules shown up there, CFP2, QSFP-DD. You can also think about a QSFP, an OSFP. We'll base it on the existing specifications that exist for those modules. We just want to identify where there's any differences that may be required for XR, if any. So, by the way, all of those are in progress. The management architecture spec is already published. Those four I just talked about are in progress, and then still on the agenda of things to be done. We want to do a spectrum allocation for PON overlay. There's many different flavors of PON out there. If you look in the 802.3 specification, there's a 1 gig, 10 gig, 25 gig, 50 gig EPONs. ITU has a series of specifications, GPON, XG-PON, XGS-PON, NG-PON2, and Cable Labs is now working on coherent PON specification at 100 gig. So we'd like to coexist with many of these, and we just have to choose, where we want the wavelengths to be for this particular XR application to coexist with these different PON standards. The XR transceivers themselves are fully tunable over the entire C-band, so we have a lot of freedom to choose where we put them. Many of these existing PON standards are in O-band, some are in C-band, so we just have to work with the customers and define and decide which are the most important ones to coexist with, and then perhaps take those to some other standards bodies and get those sort of reserved for the XR application. Continuing on, there's a northbound interface for the OpenXR controller. So working with the customers to figure out what flavor they'd like to see there in terms of standard APIs. It could be ONF-TAPI or OpenConfig, or some prefer some NetConf or RESTConf configurations. So we just have to define that and try to standardize that as best we can. Now, TROSA specs, there's existing TROSA specs for coherent applications within OIF. What we'd like to do is take that as an example, modify that if as necessary for the XR application, so that other vendors could develop these optical components that could go inside the XR transceivers. The idea here is to have a phased approach to this standardization, get it as open as we can, as quickly as we can. Some things will take longer than others. So that's why we were tackling the management first, so that these transceivers can be plugged into any number of different devices. and getting to the point where different people can make the optical components that go inside the transceivers, different transceiver vendors can make the transceivers, and then finally you'll get to a point where you'll have a specification for mid-span meet. This is the most aggressive of these. You've got to define everything going down to how the subcarriers are defined, how the powers are set, the forward error correction that you use on it, if you're using a probabilistic shaping, you know, all these types of things. Ideally, you would be able to take a DSP from one vendor and have a mid-span meet with a DSP from another vendor. We're still waiting to see that happen for simpler applications. It will take some time, but that's the goal here. And then finally, there's a southbound interface from the OpenXR controller where you're defining all the APIs required to control the XR transceiver. So that's really the full spectrum. The idea here is to make all of this open eventually, try to increase the number of vendors that are supplying these products. The more ubiquitous this becomes, the cost will go down, and we'll all enjoy the benefits of that, I think. Okay, thank you.
Test. There we go. We'll take the clicker. Thank you. All right, first a short introduction. Steve Hand, and I've been at Infinera for quite a number of years. And this project has been very much fun to work on. Dave and I looked at what the technologies can do, and then we started to identify where are the challenges going to be and how can we address the full spectrum. And you heard quite a bit about the network management, so I've been working on what are the control planes and the whole paradigm of the network management. So enough about me, let's get into the topic of proof of concepts and demos. So if you, we're now transitioning. You saw for the first time the point-to-multipoint in operation across the street. And this is going to be talking about proof of concepts that are sponsored by the various members of the OpenXR Forum. We have one from Liberty Global. I'll talk about the Lumen POC, and then just a brief of what to expect coming up next. So the first one was sponsored by Liberty Global, and I'll go right to the abstract of it. If you look, this one is to look at how XR can be deployed in a variety of different applications, point-to-point, point-to-multipoint, and to be able to test that dual management that you heard Norm talk about. So the sponsored by Liberty Global, that's Camille and Chris from Liberty Global, and then Juniper was invited, and they're participating as well. The test beds, I'll go through the test beds. There's point-to-point, multipoint, there's 100 gigahertz. There's also going over the existing infrastructure of 50 gigahertz. How can you take a 400 gig module and deploy over existing brownfield? And then a variety of different filters, ROADMs, AWG, PON. PON is a very interesting one. And then the different equipment, the XR modules themselves, variety of routers. So Juniper is participating right now. There's hope to have other routers participating, and to show that it goes over open line systems. If you look, Norm described, there's different demarcation points. There's demarcation to the open line system. There's also demarcation to the hosting devices, and it can be a variety of those devices. So part of the challenge of XR was to take all of the intelligence that the transport system has and bring it down into that small module. So it's a system on a chip and into the module. And then where will be those interface points and how can you solve those for the purpose? And this is where I like the OpenXR Forum, is how do you do that rapidly into the network using existing standards and extending the standards where necessary. Had many conversations on this already. So the first test beds are going point to point. And these, if I can get the laser, there we go. The first one is showing compatibility with 100 gigahertz point to point. And one of the capabilities is how do you upgrade these? If you had 100 gig on one side and 400 on the other side, and then be able to upgrade just one side at a time on a point to point. The next one is taking advantage of open line systems, running over a different vendor's line system to show that that demarcation point between the XR and the open line system is there, and also to show how you can start to do functionality like auto tune or auto lambda. And then the one I mentioned is over a 50 gigahertz legacy line system. How can you do 16 QAM over a narrow 50 gigahertz AWG? And this is where the control of the subcarriers, you can turn off the outer subcarriers to get it to fit into the narrower 50 gigahertz. Next test beds are testing the point to multipoint. The first test bed is just a 4x100, putting it into different devices on this side. Test bed 5 starts to test single fiber and to show how XR can control the subcarriers, turning on some of the subcarriers for down direction, some of them for up direction, and be able to be compatible with single fiber. Next is being able to go to a demarcation. Andrew has talked about this quite a bit, where if you can set your demarcation at the other end and control it remotely, now you can introduce new applications. So being able to test with the network demarcation unit at both 100 gig, and then finally being able to go down to that fine granularity of 25 gig. Okay, the other part of it is the dual management. Norm talked about that, so I won't spend too much time, but it's being able to demonstrate this in a proof of concept fashion and start to get the different ways of doing it. There's actually two ways of doing it. There's communication agent, but there's also through VLANs. VLANs will work in a variety of devices without a lot of upgrade, because VLANs are already handled by switches and routers. So VLANs would be one method to test, and that's going to be the first one tested here. And then as work is continuing to make it through the communication agent so it could reuse the existing DCN network as well as the IP addresses. If you have all these modules going out into the servers and to the routers, being able to reuse, oops, one more click here, being able to reuse the same infrastructure that is already there, being able to reuse the IP addresses gives a huge advantage to the operational aspects. And as Norm talked about, the specifications. So the timeline, this one at Liberty Global, it is already the test plans are being developed, the test beds, and so we hope to begin this in October and verifying the point-to-point test cases and the 4x100, and then in November being able to do the dual management and operate over it. Here you can see we've already started doing the integration work for the Juniper box, and Moran will talk more about that. The second POC, the first one was at the beginning of the year, and we've been developing that quite a bit. This one's more recent. Mary Hewson at Lumen is sponsoring with, the purpose is to demonstrate and test the performance of the XR modules in a point-to-point environment, and to also test this dual management. The dual management, if you look at where these coherent XR modules can be deployed, it does create the challenge of how do you manage them as they get deeper and deeper into the network in a way that can be deployed rapidly. So this scope, validating both the performance and the dual management, it will be in the Lumen Validation Lab, and it will have, this is another nice thing about the forum, is it was proposed at the forum, and then feedback was gathered. So we've added colorless MUX in addition to the ROADM and the 75 gigahertz AWGs. In a point-to-point, being able to fit over the existing line systems is important. The test will be over ULL and LEAF at different distances, and with UFI space drive nets as a preferred target. The benefits is being able to establish what the performance of XR can be, so that then this can be published in applications can then be defined around that and help establish RFP requirements, et cetera, and understanding the dual management. The scope, I think I've already covered this. So we've got testing over a variety of distances, different aggressors, being able to really characterize the performance of XR in order to define where in the network it can go, testing it with and without adjacent wavelengths, filling up the line system. And this one will also, the dual management is a very important aspect, and so these are being tested to be able to work out what are the issues. The OpenXR forum, as Norm said, this was one of the early items. How do you deploy it rapidly into the network and really innovate around the challenges there? Okay. And then the output. So it's really getting all the performance characteristics of XR, how it can, what the powers it will be able to launch with, going through the various muxing systems and testing its performance. Timeline here is its test plans are also being developed now, and it will also begin testing very late October, perhaps into November, and then the goal is to publish these results in the January OpenXR meeting. Upcoming ones. These two, the proof of concept from Liberty Global and Lumen, are being placed into routers. The discussions that we're having now in looking into 2023 is how do you put it into additional devices, deeper into the network, variety of servers, and so you can expect more to come with additional POCs. I think we're ready for Q&A. Okay.
Yeah, so pause there. There's any questions, discussion on the specifications or the proof of concept demos? Please.
Marcus Brunner, Huawei. I'm a bit surprised that you sort of changed the management architecture of this sort of orchestrated controller type of architecture, which, to my understanding, operators were sort of asking for exactly that, to do exactly, try to solve your problem. I understand the problem, but I thought the orchestrator was meant to solve exactly that. Now I'm hearing you try to use another way of doing it. And it makes it, I mean, you have a transport controller talking to a lot of different equipment in the network. Sounds a bit strange to me, to sort of like separate concerns.
If you think about what XR is doing, it is taking the transport box, it's removing the box, but all of the transport functions now need to be virtualized.
You understand the problem.
Yeah. And when you look at the OpenXR mission and goals, there are multiple ways to solve it. Some of them will take longer than others to solve, and the mission is to how can you deploy this rapidly into the network? And that's where the guidance from the OpenXR founders and the carriers is we want to deploy this into the network rapidly. We know the traditional methods will take quite a bit of time. As an example, putting modification proposal into CMIs, that's looking to take into a year, more than a year from when it was proposed, and that's a fairly simple aspect. So we're looking at, we do make changes and proposals to modify for the existing standards, and not in lieu, but and be able to provide an alternative method to manage the virtual transponder, the virtualized transponder.
But it looks like you need to change the whole operations if you do that.
It's actually the opposite.
At least
This,
from the operator I'm coming from, it would need to be like that.
if you look at where the world is going to in a disaggregated, being able to put a variety of layer separation and disaggregated separation, by putting it all the intelligence through this path, that will take quite some time. By putting the operations would be able to be consistent and providing a single REST northbound API rather than variety of the APIs here, a variety here, a variety here. So it accelerates the ability to bring this virtualized transponder to the network. And as Norm also said, it's not just XR that will be faced with this, but as you put more and more intelligence into the modules, they will also face similar type problems.
That's why I'm asking it, because it's not an XR problem
Exactly.
as such. It's
Microphone to Norm.
fundamental problem.
I think I would characterize.
Can you turn on the mic?
Text.
There.
Yeah, I think I would characterize it a little bit differently. You said that the transport controller now has to talk to all these other hosts. I think of it more as talking through those hosts.
Yeah.
Those hosts have a tunnel through them, a pipeline, so that you're still talking to the transport equipment. The transport equipment has just been shrunk down from a chassis down into a pluggable module, and it's being controlled by that transport controller. There's a path to get to it through the server, through the router. But that's really the point of that. It's a very simple pipeline through there.
Let me ask some other topic
the dual management thing, which makes me nervous as well. As coming from an operator, you don't want to have two controllers talking to the same piece. I mean, sort of equipment, pieces of equipment or something. I mean, that can a lot of things can go wrong in that sense. But it's, I mean, I'm just asking. I don't have a particular opinion on that.
So the question is, dual management, how do you prevent the problem of multi-managers? And having, And so we looked at that also in the OpenXR forum, and there needs to be a very clear separation of what are the controls from the host and what are the controls from the transport system. The host will still do, and as Norm described, the host is still going to be configuring the SerDes lanes. It's going to be configuring the things that are already there in the CMIs. The transport side is going to be controlling the things that would typically be done on the transport side. And where those two meet, it needs to be very clearly demarcated about which one is controlling it. And there is some overlap, some choices. Is the frequency coming from the host, or is the frequency coming from the transport? And so we've made the host is the master. So if the host is going to configure the frequency, it will configure it, and the transport will not. But you can also have it configured as a gray optic. And as a gray optic, then the transport system can control it. So we looked at creating a very clear separation of these parameters. Other questions?
Just to complement one of these, that the problem I think is general for the integrating in a router the transceiver. Okay, so I think it's general. Even if you have the same interface, okay, imagine that you have the same netconf openconfig interface, then you still have the problem is the IP controller going to take care of all of it? Exactly. Or you're going to send, now we are proposing, we are saying, okay, can we have this dual management of the optical controller, taking into account just the optical constraints and the transceiver part of it, and then the IP controller take care of that. So that problem is still open, and we are still looking at different solutions. And I think only by testing and doing different choices, we'll see if it makes sense to have a separate controller, optical controller, just taking into account the optical part of the routers, and taking into account that IP routers guys don't know a shit about the optical part. So it's better to keep them off.
Yeah.
Something that I think the difference that maybe exists with this solution and the same problem from other pluggable is that you are considering a tunnel, so you are completely bypassing the other host system. All the other solution, in a way, means that you have to, the optical controller has to control at the same time something which is part of the router. So you need, for example, an open config interface, what you want, netconf, but it's something that should be inside the router, embedded on it. And so you know there is a lot of problem with concurrency that may be a fault. Who is managing it? What happens if you plug out it? It's when you have plug out the modus, that is a general port, not an optical port. You can put a client-side module on top of it, on that. That's a big issue, I know. But if you bypass completely, so give to the router, doesn't know what is inside, in a way, and say, okay, I am opening a tunnel. Now, you can do potentially what you want. You can use an external software. So I'm in favor for this solution, but unfortunately, it's not the same solution others are using for other pluggables. That's the point.
Another look is the trajectory of what's going on as well. If you look at CMIs, it was started out where controlling both the line side and also the media side and the host side. And that separation that you can see is starting to be adopted into there. And XR will support those aspects. It also, that is also, the trajectory is looking at time. Any other questions, or we need to?
Okay, yeah, sure. Yep.
Ramon from CTTC. I'm working with Oscar Emilio. But related to this, I guess it's also the problem of running a piece of software, which is the agent, in the host.
Yeah.
So that moment you're opening the hardware and you need some kind of container management
That's
system,
right.
you need support from a host. So
That's right.
That to me, it's more opening your hardware than having two separate
That's right.
interfaces to the box.
So you look at the dual management, there's two ways to do the dual management. One of them is to use VLANs, and VLANs then are going through the data portion. The other one is working as a network virtualized function or an application that would be developed in cooperation with the host. And for that, now I'm going to switch hats from the OpenXR to Infinera. Infinera is working on a reference library to aid the servers or the routers, et cetera, to be able to develop that communication agent. David.
So, quick question from my side, David Tilakos, Huawei. Is there an authentication of this kind of communication foreseen? Because we're trying to mix different aspects of the network, different portions, and different might be under different control of different parties.
Yes,
so,
exactly. So the question is on authentication, and XR does have looking at, and part of the specification will be covering the security and authentication. So the modules themselves have an IDEV ID. It has certificates capability so that a module can be onboarded and verified from the controller. And with the communication agent, it actually initiates from the module itself towards the controller.
So the module will also be able to identify if it's really an authenticated controller that, that tries to control it.
That's right.
Okay.
Okay. Thank you very much.
Okay, thank you for the questions and the discussion. I think we'll move on. We have two more really exciting presentations. David Peeler from Dell Technologies. There you go, and there's your control.
Okay. I hope I'm going forward. Yes. Okay, I'm David Peeler. I'm from Dell Technologies. Press, and I pressed the wrong. Okay. So I'm from Dell Technologies, and in this talk, I'm going to follow up on the previous talk about moving XR deeper in the network and talking to things like servers. But before I do that, I want to. Before I do that, am I not loud enough by myself? Okay, so before I do that, I'd like to give you an idea of where Dell is coming from, having been in the data center world. Now, up until a few years ago, this is the only places that we put servers, that is in data centers. And servers were connected to the top of rack switches with copper cables, passive copper cables. And you know, they lived in this hierarchical data center where things were farther apart. You would have optics at the higher parts. And you know, all network interfaces had pluggable modules, like one of those acronyms. So that's the world where we come from. And the reason I'm bringing this up is because, you know, as we look on how to integrate XR optics into servers, I just want you to see where we're coming from and the problems that we have now and the way we do things now and how things might need to change on both sides so that we can, you know, meet in the middle. Okay, so edge computing is the reason that Dell no longer puts all of our servers into data centers. We've actually, in the past few years, started what we call our telco business unit or organization, and we are moving compute as the world wants to move compute resources into the network. You know, for Dell, that's great. We make servers. We want to help move servers into the network and distribute them. So there are benefits to doing that. One is that, and this is the distributed model, which is very different than the model that people were thinking about, you know, several years ago, where you had these hyperscale data centers and you had centralized servers. You have, so with the edge computing, you have disaggregated workloads. No longer are your workloads all assigned to one machine. That's something that even has happened in the data centers. At one time, there was the email server, which was a box. Now the email server no longer refers to a box or machine. It's something that can be anywhere, literally anywhere on this planet. Doing the edge computing is moving the compute resources to where they make the most sense. Compute resources cost different amounts of money when they're in different places. They have different latencies depending on where they are, and you want to kind of move those resources around in a way that is most efficient for everyone. Let's see. So, and also, it's not just the centralized server and the edge server. There's a whole hierarchy of different places in a network where the edge might be. There's the edge, the far edge, near edge, far edge, and even what I'm calling the server, which would be the far, far edge. Where XR optics come into this is as bandwidth requirements increase, the XR optics can facilitate interesting kinds of connectivity that can reduce complexity, real estate requirements, and overall cost, which is what everyone cares about. Okay, I'm gonna need that water, because I came in late and went directly to my seat. Okay. So this is just an example of a network. There are, and as I said, there are different places, different data centers in this network where you might distribute these computing resources, all the way from what is sometimes called now the micro data center or the cabinet, all the way to the core data center. And as I said, you want to distribute those resources in a way such that you get the most cost-effective network or effective network, depending on what you look at as costs. So putting the for example, the 100G XR in DU servers, this is just kind of an example where we can go directly from the core and bypass the near edge or the medium edge or the far edge to get to the far, far edge without having to actually have that real estate space, that network complexity. You can just bypass a lot of things in doing this. So the advantages, as I said before, you can bypass more than one point or more of OEO aggregation between the core network and the far edge, which is the server. The most important, I think, is that you have this this flexibility in being able to, on one hand, move resources, increase bandwidth to different servers, or move bandwidth from one server in one geographic location to another server in another geographic location. Now I want to talk a little bit about the differences in how we think about servers from the legacy data center world, as opposed to maybe the way we need to think about servers as we move them into let's call it the telco world, or the world of more advanced optical networks. First of all is power. Right now, the servers that exist, they do have, we have servers that have, what we call 200 gigabit per second servers, which might have 2 QSFP28 interfaces, or we even have, 10 gigabit servers or 25 gigabit servers, but they have fairly low power requirements, or very low power handling capability. And this is even becoming a problem as in just the data center world, because as we go to more sophisticated optics, for example, using higher orders of modulation, using optics that have DSPs inside of them, we're actually using more power than previous kinds of technologies. For example, QSFP28 servers, they've been used to having an SR optic, a short distance optic inside of them, and all of a sudden, we want to go to a more sophisticated optic from a SR4, 4 times 25G, to a optic that has one wavelength at 100G, and that requires DSP, that requires gearboxing, and the power requirements go up. So it's not exactly a good fit, even in the data center world. The XR optic is, at least on the 100G side, is going to take a little more power, and that's going to take a little more engineering and thought on our side. Additionally, there's the issue about management capabilities. Today, our servers barely talk to the pluggable optic. In fact, most of our servers in the world don't even talk to an optic because it's a passive copper cable. So they don't even think, that's not even a part of what people think about when they put together servers, is managing this device that plugs into it. So that has to be something that is taken into account, from the server side as we start thinking about how we're going to put these deeper into the networks. And just to repeat what some other speakers said, this is not just an XR issue. This is an issue relevant to all types of pluggable optics. Okay, so here's just an example of how the management system might, be set up. This is, perhaps a model for a proof of concept in 2023, perhaps. This is something we need to test out and figure out how to do. But, the point here is you've got these two different kinds of management systems, and you want to get them to somehow work together. And for us being everyone, to understand how we need to change things or move things around such that we have an effective system. So I think that's my presentation, and I'm guessing we're going to wait for the next to give questions.
Until after Moran.
Great. So.
Okay, so I wanted to give the perspective of integrating XR into switches and routers. But before going there, I wanted to put it in perspective of historical trends in coherent technology. It started with integrated modules many years ago that went typically into traditional transponders. Then it went pluggable. But the big leap was done with QSFP-DD and 400 gig ZR. This is when coherent could be integrated into routers and switches without compromising the density. It started with DCI applications, and then with ZR+, and especially the advancement of 0dBm, a variant of ZR+, it goes into metro and regional networks. So as you can see, the advancement is going toward us, toward the edge. And this is really, what XR provides. It's one of the technologies that can carry coherent technology toward the edge. So what applications do we see in this integration to switches and routers? It's similar to what Andrew, Emilio, and Oscar showed. It's in metro aggregation, where the nature of the aggregation network lends itself, instead of digital aggregation, to optical aggregation. So you can envision an XR domain where this optical aggregation is taking place. And further into the edge with wireless aggregation, where we can see either front haul or back haul aggregation network take advantage of this technology. Now, Oren defines too many, in my view, models of these networks, where the equipment, which type of equipment, what is virtualized, what is physical, and the devil is in the details. So this is really where we are looking to engage on specific use cases in order to analyze and show the benefit of this integrated technology. So what are we doing with Infinera? Steve showed a bit of the integration that we are doing. We are working on these, integrating XR into one of the routers currently at Juniper, the PTX. This will be a model for, it's the same software, so it will be a model for different routers and switches. And we are working on the proof of concept planning as part of the XR forum that Steve described. And lastly, we would like to see this standardized. This interface is standardized, and one of the activities is enhancing CMIs in order to allow this management of the XR within the host interface. Whoops, I did something wrong. Okay, thank you.
Thank you, Moran. Okay, thank you, Moran. I'd like to thank all of our speakers. We have a few minutes left, so if you have some questions for David or Moran, let's use the time for that discussion. No, if not, I'd like to take a minute, ask Dave Welch to give us some any closing comments. Before you all rush out, there is lunch outside. We did promise lunch. It didn't make it inside on your way out. Please grab a sandwich or I'll have to take them all home.
Great. Thanks, Phil. Thank you guys for your time today. This is really the start of some significant and exciting progress, and to be able to get the technology out into the field and getting everyone's comments on what that means is important. I want to emphasize that the capabilities of XR really define a point-to-point configuration in addition to these point-to-point, point-to-multipoint types of applications. And as a result, as this as a body to drive a ecosystem around the technology, it's around about embracing both of those applications. The management system is really about managing smart optics, regardless of whether it's in a point-to-point or point-to-multipoint type application. And what we're trying to achieve with this ecosystem is the end user needs to define what is it that they want, and what is the specifications that you want in a standard that gives you the most value. We believe that the flexibility of this type of architecture creates tremendously more value out there than some alternatives, because it satisfies both of this functionality, and we encourage the engagement in that to be able to establish exactly what you want in that process, and then we can move it into different application spaces. So with that, I really want to thank everyone for their time, and look forward to working across the board with the industry to be able to create a new paradigm on how optics gets deployed in the network. Thank you.
So if you would like to learn any more about the OpenXR forum, stick around. You can ask various people who have spoken. You can go to the openxrforum.org if you're interested in membership or any of the publications we talked about today. But thank you again, and enjoy the rest of your time at ECOC.